So I just wanted to spend a little bit of time going over a couple of things we did about rational roots. So make sure we covered them. So when we have to write a polynomial of least degree and we've got a root that's a real and a complex root, what we have to know is how to use the complex conjugate. So in this one, I'm going to write a polynomial that has roots of x equal 3 and x equal 3 minus I. If it has real coefficients, I'm also going to have a root of x equal 3 plus I. So my polynomial is going to look like this. F of x is equal to x minus 3. That's the first factor. X minus 3 minus I, that's the second factor. And x minus 3 plus I, that's the third factor. So that's the polynomial. Now the work is just multiplying all this out. So we can simplify it a little bit by saying f of x is x minus 3, and then x minus 3 plus I, that's that minus and minus, and then x minus 3 minus I. So I need to multiply all these together. The easiest thing to do is to multiply those two terms. The whole reason we're doing this is those will multiply so that I'll get no I. So everything will be real numbers. So it's just a matter of being organized to do that multiplication. So I'm going to write x minus 3 minus I. That's being multiplied by x minus 3 plus I. So every term is multiplied. 3 things are multiplied by 3 things. I have 9 things here. So x times x is x squared. Negative 3 times x is negative 3x. And x times negative I is negative ix. And then go to the second row. Negative 3 times x is negative 3x. Negative 3 times negative 3 is 9. Negative 3 times negative I is 3i. Go to the next row. I times x is ix. And then negative 3 times I is negative 3i. And then negative I times I is negative I squared. But since I squared is negative 1, negative I squared, this is just simply going to be 1. And then what we see is ix cancels with the negative ix. The 3i cancels with the negative 3i. So everything with an I is gone. And I'm left with x squared minus 6x plus 9 plus 1. So that is going to be x squared minus 6x plus 10. So if I go back to my original, I've got f of x is equal to x minus 3, and then what I just found here, x squared minus 6x plus 10. And I need to multiply all of this together. So I'm multiplying x squared minus 6x plus 10, multiplying that by x minus 3. X times x squared, that's going to be x cubed. And negative 6x times x, that's negative 6x squared. And then I get 10x. Go to the next row. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 6x is 18x. And negative 3 times 10 is negative 30. So when I put all of that together, I get f of x is equal to, I've got my x cubed. This is negative 9x squared. Let me go back. This is an x cubed. X cubed minus 9x squared plus 28x minus 30. There we go. So that is multiplying when you have a complex root, and you have to multiply with a complex conjugate. So something very similar is the very next question, where we have something that has an irrational root. So in this case, it's very similar. My roots, in this case, are 4, 1 plus root 5, and 1 minus root 5. So I'm going to write my polynomial as f of x is x minus 4. That's a factor. The next factor is x minus 1 plus root 5. And then the next factor is x minus 1 minus root 5. So the thing you have to pay attention a little bit with this double parentheses here. But this simplifies to f of x is x minus 4. And then x minus 1 minus root 5. And then x minus 1 plus root 5. And then what we want to make sure you do, the two things you multiply together first are these last two terms, because if you do it correctly, everything with the square root of 5 is going to go away. So I'll come over here and I'll just write x minus 1 minus root 5, and then x minus 1 plus root 5. So I'm multiplying all of that together. So x times x is x squared. Negative 1 times x is negative x. X times negative root 5 is negative root 5 times x. And then go to the next row. Negative 1 times x is negative x. Negative 1 times negative 1 is 1. Negative 1 times negative root 5 is root 5. And then to the next row, x times root 5. That's root 5 times x. Negative 1 times root 5, that's negative root 5. And then negative root 5 times root 5. So root 5 times root 5 is 5. You put a negative in there and this becomes negative 5. And so what we see here is this negative root 5x cancels with the positive root 5x. Positive root 5, negative root 5, they go away. And what I'm left with from this multiplication is x squared minus 2x, and then the 1 minus 5, that's minus 4. Okay? So if I go back, what I just found, that's going to get substituted in this equation. So I'll have f of x equal x minus 4 times x squared minus 2x minus 4. So now all I really need to do is just to multiply this, and I'm done. Let me create a little bit of space here. So we'll come over here and do that multiplication. So I'm going to have x squared minus 2x minus 4 multiplied by x minus 4. So x times x squared, that's x cubed. X times negative 2x is negative 2x squared. X times negative 4 is negative 4x. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 2x is 8x. And negative 4 times negative 4 is 16. So there's some things that are going to combine here. The x squared terms are going to combine, and the x terms will combine. So when I put this together for my final answer, I'll get f of x equal x cubed. And then I've got negative 4x squared, negative 2x squared, that's negative 6x squared. And then the 8x minus 4x, that's plus 4x, and then plus 16. So that's my final polynomial. So real quick, I just wanted to just make sure that you saw the difference between the complex roots and the irrational roots. So all you really have to do is when you have a complex number, like 3 minus I, the root will also have to be 3 plus I. So just a negative in front of the I term. And with the irrationals that look like the square roots, if I give you whatever I give you, a plus square root of 5, you're going to have a minus square root of 5 on the other one. And if it was a minus to begin with, it would be a plus. So anyway, hope this helps. Thanks.